Hello everyone, I'm Asmer Tashkan and I'm a mechanical engineering student. Today I'll be presenting my Physics 102 laboratory final project, measuring the Lorentz force using a digital scale.
In physics, a current carrying wire in a magnetic field experiences a Lorentz force. The formula is simple. Force equals current times length of the wire times the magnitude of the magnetic field. However, instead of using complex pendulums or springs to measure this mechanical force, we choose a much more simpler method: Newton's principle of action and reaction. If the current in a fixed wire feels an upward magnetic force, the magnet beneath it must be pushed downward with the exact same force. Our experimental setup has 0 moving parts. We placed our magnet on a precision digital scale and tailored it to 0. We passed a 20 cm long fixed copper wire above the magnet without touching anything. Our goal is to observe the phantom mass, which is caused by Lorentz force from an increase on the scale when we supply direct current to the wire, which directly corresponds to the Lorentz force. The results were exactly as we expected. As we gradually increase the current from 1 amperes to 5 amperes, the mass change reading on the scale increased proportionally. For example, as you can clearly see in our video, when the current was exactly 2.09 amperes, the scale showed a constant reaction force of 4 grams. Even this instantaneous data point was perfect proof of how flawlessly our system worked. When we plotted the experimental force versus current graph using our data, we found a perfect linear relationship between them. Using the slope of the graph and our 20 cm wire length, we calculated the experimental magnetic field strength of our magnets at this point. The result was 0.094 Tesla. Compared to the magnet's normal value of 0.1 Tesla, we only had a 6% margin of error. So, where did this 6% come from? Our error analysis showed that the main reason for this deviation was the 2-gram resolution limit of the digital scale we used. Instead of showing smooth decimals, the scale rounded the force reading to multiples of 2.
In summary, this experiment showed us how the laws of electromagnetism and classical Newtonian physics perfectly combines in a single, simple setup. We successfully measured the Lorentz force without using any complex and moving mechanisms. I hope you enjoyed this video. Thanks for watching.